Hello everyone. In this tutorial, we will now see how to set up a case in CAENexus. You can see here on my screen, I have opened the abstract model file from the scratch folder. So in earlier tutorial, we have seen how to create these meshing related attribute. And now we will see how to create other attributes which belongs to these three tabs, that is solution strategy, problem definition, output tab. So let's first start with the solution strategy tab. Under solution strategy tab, we generally specify the solution related parameter. For example, what kind of analysis we want to do. So those details we specify here. So let's see how to create the attributes from this solution strategy tab. We will first create analysis attribute. So I'll just click on this global class. Then in solution strategy tab, I'll click on create. I'll go in Accusol global commands. Then I'll select analysis and I'll just click on static because I want to do a static analysis. And then I'll click on close. So this way I have created analysis attribute. Similarly, I'll create equation attribute. So again, I'll select global class here. I'll go in create Accusol global command. I'll just select equation and then specify. So here I'll just select turbulence as this Ballard Almaraz mod and I'll click on apply close. Again, all the other details from these attributes, those are in line with the Accusol documentation. So all the Accusol user, they are familiar with all these inputs, so they can specify the details as per their requirement. Timing, I'll just select this turbulence and I'll just close this attribute. Similarly, I will create auto solution strategy attribute. So I'll click on global class, then create, then Accusol solution strategy command. I'll select auto solution strategy and then specify. I'll keep all the values as it is and I'll just click on close. So this way I have created attributes from this solution strategy tab. Let's now create attribute from this problem definition tab. So generally here we specify our boundary condition, initial condition, some material details. So we'll see how to specify those details through attribute. So firstly, we'll set a length scale factor here. So for that, I'll just click on global class. Then I'll click on create and I'll just select length scale factor. Now the model which we created in CAD, its unit is in millimeter, whereas the default unit of Accusol is meter. So just for the unit conversion point of view, we need to specify this length scale factor. So I'll just specify here 0.001 in all the three direction, that is XYZ. So with this, what I'm doing is I'm converting my millimeter unit to meter unit. I'll just click on apply and close. So this way I have set up a length scale factor. Let's now create a material attribute. So we'll create air material. So firstly we'll create a respective density and viscosity. So for that I'll just click on global class. I'll go in create. Then I'll just select the Accusol material model, then density model, and I'll just select constant function. So here I'll just specify the density, that is 1.225. Maybe I'll give name as air density and I'll click on apply and close. So this way a density attribute is created. Similarly, I'll create viscosity attribute. So I'll just go in global, create Acusol material model, maybe viscosity model, and then constant function. So I'll put name as air viscosity, and the viscosity value I'll give is 1.1751 e raised to minus 5, and I'll just click on apply and close. So this way density and the viscosity attributes, those are created. Now we'll create the air material model. So for that I'll again click on global class, I'll go in create, I'll go in Acusol material model, then I'll go in material model, and I'll click on specify. So here I'll write air material model, and I'll just refer the earlier created density attribute here. Similarly, I'll refer earlier created viscosity attribute, and I'll click on apply and close. So this way we have created the material attribute for air. I will just change the viscosity value here. So it's not 1.1751, it's 1.751. Let's now create element set volume attribute. So for that I'll just select air class here, then I'll go in create, then I'll just select the Acusol element data commands. I'll just select element set volume, and I'll select specify. I'll maybe give name as air element set volume. I'll select medium mass fluid here, and I'll just refer earlier created material here in this material model, and then I'll click on apply and close. So this way element set volume attribute is created. Let's now create some attributes related to initial condition. So for that I'll first click on model class, then I'll click on create Acusol nodal data commands, nodal initial condition, and then I'll select pressure and specify. So here we'll specify value as 0. Similarly, we'll specify the velocity attribute. So I'll just click on model class, create nodal data commands, nodal initial condition, then velocity and specify. So we'll keep the values at 0, and I'll just close this attribute. Similarly, we'll specify one more nodal initial condition, that is to ED viscosity. So I'll click on create nodal data commands, initial condition, and then ED viscosity and specify. So maybe I'll give some non-zero value here, 1 e raised to minus 4, and I'll click on apply and close. So this way initial condition attribute can be created. Let's now create some boundary attributes. So we'll specify inflow, outflow, and wall. So for specifying inflow boundary condition, I'll select this relation, that is relation between fluid and inlet 2D. Then I'll go in create Acusol element data commands. Then I'll just select simple boundary condition, and I'll select inflow here. So here inflow type I'll set it as mass flux, and I'll put value as 0.1. Then I'll click on apply and close. So this way inflow boundary condition attribute is created. Similarly, I'll create the outflow boundary condition. For that I'll select R fluid outlet underscore 2D relation. Then I'll click on create. then elemental data commands, simple boundary condition, and outflow. I'll just click on close and the attribute is created. Similarly, I'll create the wall boundary condition. So for that, I'll just select the boundary inside of fluid. I'll click on create, elemental data command, simple boundary condition, and I'll click on wall. Then I'll just close this attribute editor. So this way I have created the boundary condition specific to viaduct model. Let's create a non-physical surface on fluid-fluid relation. So I'll just click on this relation, then I'll go in create, select non-physical surface, and then I'll click on standard and I'll close this attribute. So this way attribute for non-physical surface is created now. Let's now create some attributes from the output tab. So AccuSolve, it allows to monitor some field parameters and there are some commands for that. So in our case we'll just monitor our inlet and outlet surface. For that I'll first select the relation between fluid and inlet 2D, then I'll go in create, then AccuSolve element data commands, surface output, and specify. I'll just close this attribute. So this way surface output at the inlet is specified. Similarly, we'll create the attribute for the surface output for outlet surface. So for that I'll just select relation between fluid and outlet 2D, then I'll go and create element data commands, again surface output, and specify. I'll then close this attribute. So this way, with the help of classes and relation, one can set up the attributes which covers the physics of your problem. So a quick recap: in solution strategy we specified the attribute which covers what kind of analysis we want. Under problem definition, we set up some attribute which covers physics like your material details, your initial boundary condition, your simple boundary condition. And in output tab, what kind of output you want to monitor, those details you can specify through attribute. So this is how one can set up the case with the help of classes and relation in CAENexus workflow. So I will just save this abstract model file. This way one can set up the physics with the help of attribute in CAENexus workflow. So that's all from this tutorial. I thanks everyone, and if you have any question or any queries, then please feel free to contact at support@novusnexus.com and we'll get back to you accordingly. Now in next tutorial, we'll see some more details about simulation model. Till then, have a good day. Bye.